In this lesson, we'll look at a problem that involves partial derivatives and the Laplace's equations. So the question says, show that z, which is equal to fx, y, is equal to e to the power x sine y, is a solution to Laplace's equation. So the first thing that we do, we have f x, y is equal to ex sine y. So we are going to find the partial derivatives of this function. So we'll find the first partials, which is d f x, y with respect to x. Okay, we are finding partials with respect to x, so sine y will be treated as a constant. So now, when you find the derivative of e to the power x, it's this same function here. So this is what we have as the first partial derivative. And then we are now going to find the second partial, which we call d2 f xy dx2. So the second partial derivative of this function here is also going to be e to the power x sine y. And then now, the next thing is to find the partial derivatives with respect to y. So we are going to have d2 or df delta fxy delta y is equal to, okay, so now in the second one, we are differentiating with respect to y. So the function that has x here will be treated as a constant. When you are dealing with partial derivatives, that's what you do. So since we are doing it with respect to y here, we are now going to have e to the power x to remain as a constant, and then the derivative of sine y is cos y. And then we are going to differentiate it again. We'll find the partial derivative again. So d2 f xy dx2, this is the second order partial derivative. So you differentiate a function partially, and then you differentiate it again partially, and you have a second order partial derivative. So here, e to the power x, here it's supposed to be y, e to the power x will be treated as a constant, and then cos y, when you find dy dx for cos y, what you get is negative sine y. And so this is going to be negative e to the power x sine y. And so therefore, for you to prove that this is a solution of Laplace's equations, you are going to add the two second order partial derivatives. This one here, the one that we found first, and then the second one that we found with respect to y. So the second order that we found with respect to x, and the second order partial that we found with respect to y. So when you add the two second order partial derivatives, this one here with respect to x plus with respect to y, okay, d2, okay, dy2, even here you have a 2 there, you should be able to get 0. And so here, our two equations for the second order partials, we have e to the power x sine y plus negative e to the power x sine y, which will give us e to the power x sine y minus e to the power x sine y. And this is going to be equal to 0, and therefore this is a solution of Laplace's equation. Thank you.